Hello and welcome to a new part of the music theory course. Now we're going to look closer at tones when being played at the same time. Here we have an application that I have developed several years ago. With this, we can analyze sine waves graphically and also hear them. The tones are going to be displayed in octave 0 because they have low frequencies that are easier to see on screen. But the sound being played will be transposed 4 octaves up to be able to hear them better. But the point of the test will be the same. First line shows the tones unmixed, and the second line will show them mixed together. I will add the first tone, C0, as also will be our root tone throughout the whole test. A C0 has the frequency of 16.35 Hz, which means that it makes 16.35 cycles between these two black second markers here. And this tone sounds like this. Now I'm going to add a green C0 sine wave to the mix. Now you could see that the mix of our two tones increased the amplitude by the double. This happened because the two tones was mixed digitally, so that 1 plus 1 is 2. But this doesn't happen in the same way when mixed in the air, as we're going to talk about in a later part. But here it will be double, because both tones are in the same frequency, amplitude and starts at the same time. Now I'm going to change the green C0 to a C sharp 0, and then we can see the green C sharp peek through here. Now because this tone has a little faster frequency than our root tone C0, the interval between C0 and C sharp 0 is now a half tone step, which I know is the worst interval to take simultaneously. Mixed, these two sounds like this. Not good. Yikes! We can now see here that the amplitude is increasing and decreasing in its own wave. If zooming in where the amplitude is going down, then we can see that one of them wants to push air and the other the opposite. And a positive value plus a negative value that is equally big will have the result of 0. We can also see here that they are starting to push the air more together, and a positive value plus a positive value will give us more smack in the face. This modification of the amplitude will our ears also hear as one more frequency, where each 0 in the amplitude wave can be compared to a new bar line that together are building the actual beat bars. Every positive and negative peak can be compared to a beat note on a drum. We want all of the beat notes to be placed as rhythmically as possible within a beat bar to build a nice harmony for our poor little ears. We don't want to buy a drummer on the flea market. We want a professional studio drummer for this. Please? Here I have cut out some test parts from our C0 and C sharp 0 from various places in the mix. I have put 2 lines at each side of the amplitude mountain. And I've put a line on each peak as a guideline. I'm using this first test part as a template where I've placed each line on every peak, and also my 2 lines in the beginning and in the end of the amplitude mountain. These guidelines will reveal changes in the rhythm between the different test parts. Now, let's look at the next cut. That is a sample taken a little bit further into the mix. Here, we can see that the left green line is at a guideline, and each peak is also still on each line. This shows a great beat in the seat. But we can also see that the last red line is now falling a bit short compared to the previous sample and is now out of beat between 2 guidelines. This shows that the amplitude mountain has gone down to 0 earlier. And if we are looking at the amplitude mountain that comes directly after this one, as also will be our third sample, then we can see that each peak in the wave is in backbeat. And the red line to the right is still out of beat, which shows that the harmony between the peaks and the amplitude wave isn't really in harmony to each other. Now let's look at sample 4, taken even further into the mix. Here we can see that the length of the amplitude mountain is shorter, but is now in beat again, where both of the lines are at a guideline. But the peaks are out of beat all the way, which tells us that the harmony between these two tones are sliding around all the time. Test sample 5 shows us that the peaks are in backbeat again, but the length of the amplitude mountain has increased and are now out of beat again. Test sample 6 is showing us that the peaks are a bit late to be in backbeat. Now they are all out of beat, and the length of the amplitude mountain is a tiny bit longer, where the right red line is placed more out of beat from the guideline. And on the last test sample, each and everything is in backbeat to the guidelines. The sum of all of these test samples is that the harmony slides around all the time, building a really bad harmony between the two tones C0 and C#0.
We want better rhythm than this!
And that is what we are going to get. Now I'm going to show you how it looks like when our root note C0 is mixed with an E0. The interval between these two is a major, and that is the interval of happiness. You better be smiling! And these tones sounds like this together. Much better. Here is a new test, where I have cut out parts the same way as previous, but this time with a C0 and an E0. In the first test sample, we can see that everything is at a guideline. The two lines and all the peaks. But in the test sample 2, we can see that the peaks are in backbeat. But this is also true for the red line at the right of the amplitude mountain. And this shows us that this is in the beat, even if it is in backbeat. So it is something like this. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4. And in test sample 3, all of them are back in beat again, at every guideline. And we can also see that the rest of every test sample are showing the same thing. It varies between these two, in beat and back into backbeat, in a nice harmony with the amplitude mountains. Therefore, these two tones sounds much better than in our previous test, where the two tones only had a half tone step interval between each other. And now we will change our green E0 to a G0, so that the interval between our root tone C0 and the green G0 will be a fifth. And these two together sounds like this. Totally ridiculously great! Here we also have some cutouts from the mix. In test sample 1, we can see that the green and the red line are placed at a guideline, and each peak are in perfect backbeat. And test sample 2 shows that the length of the amplitude mountain has the same length as before, and the peaks are placed at each guidelines. And all of the samples are showing the same thing. Now the length of each amplitude mountain has precisely the same length wherever I'm looking, and it varies between on beat and in backbeat, which makes it sound as beautiful as it does. But if we now are backing up to the beginning, where we mix the two worst tones, C0 and the C#0, that only had one half tone step between them, then it sounded awful, where they together created those long amplitude changes that were out of beat compared to the frequency of the complete mix. But the higher up you take the C# from the root C0, the C sharp will start to transform into overtones. With other words, the long changes in amplitude will disappear into overtones and not be so obvious to our ears anymore. Let's hear this on the keyboard. As you now could hear on the keyboard, it sounded better the further away from each other I played the two notes. And here we can see that I have transposed the C sharp 2 octaves up, which clearly shows that it became overtones, and is interfering with the root tone C0 less, with its fast changing values. The result is less noticeable to our poor little ears. And with this long experiment, I would like to thank you for listening. Don't forget to subscribe for more. Bye!